Hi everyone, this is 1.2 speed and velocity. So average speed, I'm going to put in my little AV here, is the total distance divided by the total time. Pretty straightforward. V is equal to delta D over delta T. Velocity has a little half arrow or full arrow above it to denote that it's a vector. And this is the displacement or change in position of an object divided by total time. As we looked at in our first lesson, we know that distance and displacement are not necessarily the same thing. So an object can have a different speed and a different velocity. When it comes to the equation, we could separate it into its parts as the velocity being d2, position 2, minus position 1 divided by t2 over t1. But more often we can put the equation together like this with our half arrows, and this is the equation we end up using most often, especially in a word problem. You'll notice the formulas look the same, but distance and displacement are different values, therefore speed and velocity are often different as well. Let's try an example. A runner jogs with an average velocity of 3.2 meters per second west for 25 minutes. What is the displacement of the jogger? We're going to use the guess method, so we're going to write out the given, the unknown, the equation, substitute, and solve. So from the word problem, the velocity was given, the time was given, and the displacement is unknown. At this point, we should see a problem with the units. We have the unit for time as part of velocity in seconds, and then the time has been given in minutes. We need to make sure that these actually have the same type of unit. So remember from our conversions lesson that 1 minute is the same as 60 seconds. We can use this as a conversion factor. So I'm going to convert the time into seconds. So I want to know how many seconds is in 25 minutes. I'm going to use the 1 minute equals 60 seconds as my conversion factor. I'm going to put 60 seconds on top since I want seconds as my unit. I'm going to put 1 minute down below so that I can cancel the minutes unit out. And when I do my math, I get 1,500 seconds. Now I'm ready to do the next part of the guess method, which is the equation. So my V is equal to displacement over time. I'm looking for my D, so I'm going to get T off the bottom. When it goes over the equals, it does the opposite math. So right now it's dividing. It's going to multiply when I bring it over the equals. So there is my rearrangement. When you substitute, if you want to flip-flop what side everything is, that's totally fine. That's what I'm going to do right now. And I'm going to substitute my V, 3.2 meters per second west, times my time. Whoopsies. I almost forgot to use my new time. 1,500 seconds. Because this is meters over seconds, seconds will cancel because I've got a seconds on the bottom of a fraction and also on the top. So my final answer then will end up being 4,800 meters west. By substituting in the units and the direction, hopefully you'll remember to make sure you have the correct units and direction. The last thing we want to consider, of course, is significant digits. If I go back to my given values, the lowest number of significant digits is 2. A number like 4,800 is 2 significant digits. Because it's calculated, the zeros don't count. If we weren't sure, though, we could also put the final answer into scientific notation by moving that decimal 3 places to the left, and that would also give me a correct answer. So either of these answers are both 2 significant digits. They both include meters, which is the correct unit, and they also include direction, which is needed for a displacement. This time you're going to try it before you see the answer. So a skateboarder skates at an average velocity of 3.1 meters per second west for 16 meters west. How long does the skateboarder skateboard for? So you're going to pause the video, set it up, and then you're going to press play when you're ready to see if your answer matches mine. So I've just got things set up here. We've got our velocity, our displacement, and time is unknown. When we use this equation, the rearrangement is a little bit tricky because time right now is on the bottom. We need to isolate it and also get it on the top. Our first move is to bring it over the equals so that it becomes on the top, like so. Whoopsies. And then again, we want delta t by itself, so we're going to kick out that v across the equals. And again, when you bring it across the equals, it does the opposite math. So our delta t then is going to be our delta d divided by our v. Now we can substitute and solve. So we have 16 meters west divided by 3.1 meters per second west. You'll notice some things are going to cancel. We've got meters on the top of the bottom. We've got west on the top and the bottom. So our final answer here will be 5.2 seconds. Time is not a vector, so I shouldn't see direction. I do need a unit, which is seconds, and I want two significant digits. Again, going back to the given values, they both have two significant digits, so I also want two significant digits. So your homework is on page 15, 18, and 20, all word problems to help you solve for speed and velocity.